So in this learning target mathematical modeling, we've studied three different types of functions: linear functions, quadratic functions, exponential functions. What we know is that a linear function has a common first difference between the outputs. And when we plot those points on a graph, we get a linear graph. A quadratic function has a common second difference between the outputs. And when we plot those points on a graph, we get some sort of a parabola that opens up or down. And then thirdly, we got these exponential functions. They don't have a common first or second difference. They have a common factor. And when we plot those, we get some sort of an exponential growth or exponential decay functions. So let's go through this, the murder of Kanye West problem, just to see what we got here. It says, and answer your questions. Does a mathematical model below have a common first difference, a common second difference, both, or neither? So I'm going to find the first difference by making a third column in this chart. And the first difference basically means I'm taking the difference between the outputs. Well, I can't take a difference with just -3. There's nothing to take a difference of. But I can take a difference between 2 and -3. Difference means subtraction, so I'm going to say 2 minus a -3. That's equal to 5. I can take a difference between 2 and 1 by taking 1 minus 2. That's equal to -1. Here I can take -6 minus 1. That's -7. And then finally, for my first difference, I'm going to take -19 minus a -6. Which gives me -13. So I can see they don't have a common first difference, right? Because I got 5, -1, -7, -13. But let's check to see if they have a common second difference. So I make another column here for second difference. I can't take the second difference there, and I can't take a second difference of just 5. But I can take a second difference between -1 and 5. And second difference means I'm taking the difference of the differences. So if I have -1 minus 5, that gives me -6. This one here, I'm going to have -7 minus a -1. That equals -6. And this third one, -13 minus a -7, that also equals -6. Which basically means to go from 5 to -1, I'm subtracting 6. To go from -1 to -7, I'm subtracting 6. And then to go from -7 to -13, I'm subtracting 6. So they have a common second difference. So that's going to be my answer here. Common second difference. Kim Kardashian is the one who murdered Kanye West. What a crime. All right, second problem. You know, mathematical model is linear. We just talked about this now. If a common factor exists, nope, it's not a common factor because that would be exponential. There is neither a common first or second difference within the outputs. That's not true either. A common second difference exists. Nope, it's not a common second difference because that's quadratic. And then a common first difference exists. And yes, that's what we're talking about, a common first difference. And a linear function cannot have a common first and second difference. So we got Kim Kardashian, who killed Kanye West, murdered him with a set of hair clippers. All right, is this model linear, quadratic, or exponential? So now I have to do the legwork here. So I'm going to add a column for the first difference. And what I'm trying to see is, do I get a common first difference? So this is going to be 4 minus 16. That's -12. Well, I can see here, when I take 1 minus 4, that's certainly not going to be -12. That's -3. But I'm going to keep going here because I need to find a second difference too. So 0.25 minus 1, that's -0.75. And then my last one, when I take 0.0625 minus 0.25, I get -0.1875. So I know it's not linear, okay? But now let's check for quadratic. So if it's quadratic, I'm going to have a common second difference. So -3 minus a -12. That gives me 9. But I can see now that when I take -0.75 minus a -3, that is not going to equal 9. I get 2.25 there. So I'm going to stop right there because I know it doesn't have a second difference, so it can't be quadratic. Okay, now it might be exponential. All right, so if it's exponential, we have to check for a common factor. Now, that has nothing to do with the first and second difference. So I'm going to erase those, and I'm going to make another column for a common factor. Now, to find a common factor, factor means multiplication. So I want to know, what am I multiplying 16 by to get 4? What am I multiplying 4 by to get 1? And so on. So to find what I'm multiplying 16 by to get 4, I can simply take 16 divided by 4. That gives me 4. To figure out what I'm multiplying 4 by to get 1, I'm going to take 1 divided by 4. I'm going to take 4 divided by... Hold on, I said that wrong. My fault. Go back. To figure out what I'm multiplying 16 by to get 4, I'm going to take 4 divided by 16. That gives me 0.25. So basically, when I take 16 times 0.25, I get 4. When I take 4 by 0.25, multiplied by 0.25, I get 1. When I take 0.25, when I take 1 times 0.25, I get 0.25. So this is how we find this common factor. We use division to do this, and this one's going to be 0.252. So since I have a common factor, then I know it's exponential, and exponential, we have that it happened in the backyard pool. All right, and then the vertex here, this is just a trip down memory lane. Remember, the vertex is going to be the opposite of what you see inside the parentheses, and then it's going to be the number that you see on the outside, -3, -5. So -3, -5 is because she disagreed with him politically. All right, and then this bonus question, what is the common factor? So we know it's exponential because they're asking for a common factor. All right, well, to find that common factor, I can't find one there. I'm going to take the second output, 5, divided by the first. 5 divided by 4, that's 1.25. I'm going to take 6.25 divided by 5. That's 1.25. And you can see when I keep doing this, I'm going to get 1.25 the whole way. So then I know that the common factor is going to be a 1.25. And that's how you figure out these problems.